Welcome back to another demo. In today's demo, we're going to take a look at semiconductors through the use of LEDs. LEDs are semiconductors. When the atoms are further apart, their energy levels and electron configurations are individual to that atom. However, when atoms come closer together, the electrons of one atom start to see the electrons in the nuclei of other atoms.
Electron energy bands are formed when the individual electron states split into a series of closely spaced electron states. If the valence band is full, the conduction band is empty, and there is a smaller band gap, you have a semiconductor. At room temperature, electrons can jump and are now free to move around and conduct.
Wavelength is associated with color and it's related to band gap. The shortest wavelength produces the color violet, while the longest wavelength produces red.
Here is our LED. The longer end is the cathode side and is associated with the conduction band. The shorter side is called the anode and is associated with the valence band. The valence band is full of holes that electrons fall into as they pass from the cathode to the anode side. In between these bands is the band gap, previously mentioned. The band gap is responsible for the color of the LED as it dictates the energy difference. Photons are released as light energy as electrons go from the conduction band to the valence band, and the size of the band gap plays a role in the wavelength emitted. Liquid nitrogen cools things down and the electrons lose thermal energy. This causes the band gap to increase and it becomes an insulator. As it heats back up, notice the color change as it becomes a semiconductor once again.
Thank you for joining me to learn a little bit more about semiconductors, and I'll see you on the next one.